I hope we're live now. Yep, I think we are. So, hello everyone, and welcome to the stream. My name is Winterbolt. Today we're going to be creating a multiplayer first-person shooter using fish networking. It's going to be a basic game, like we'll have shooting, we'll have a basic movement system, and a lobby and waiting system for the game. Okay, so hopefully it'll teach you the basics of how to get started using fish networking and give you an idea of how powerful it is. Okay, we will be using the latest pre-release as of today, which is 14.6 1.4.6 pre-release 0. Okay, I'm going to leave links to the downloads and the project once the stream ends. Okay, so I have went ahead and created a new Unity project in Unity 2021.3. It's the LTS version, and I have just added some basic materials, a couple of scenes, and imported the free version of fish networking. Okay, so before we continue, I would like to apologize for any background noise that might happen. You know, I have a very big window in my room and my PC is loud as a jet. Okay, so I hope this doesn't annoy you so much. Okay, so let's get started by first creating our network manager. So right click in your hierarchy, create a new empty object, and let's call it network manager. Let's go ahead and click add component and add a network manager component. Okay, once we do so, we need to go ahead and assign the spawnable prefabs list or asset. Okay, and I'm going to change my persistence settings from destroy newest to destroy oldest. Okay, and now let's go ahead excuse me, and create our network UI. Okay, like the menu that will allow us to start the game or stop the game. Okay, so let's go ahead and right click here, create a new folder, call it scripts, and we're going to right click and create a new folder and call it UI, and right click and click create new script, and let's say multiplayer menu. Let's open it up in Visual Studio and let's begin writing some code. Oh, hello Bogdan. You're asking what's my experience with fish networking. So I have been using fish networking for I think about 7 or 8 months now, and it is a very powerful solution in my opinion. It's the best out there in my opinion when it comes to creating games in multiplayer games in Unity. It has so many features, and just overall it has a nice feeling to it when you're using it. Plus the performance is amazing compared to many other solutions. Okay, so I hope this answers your question, and let's go ahead and continue now. I'm going to make this class sealed. I'm going to remove the default code inside of it, and now I need to add some references to UI components. So we're going to have a button for hosting again, another one for connecting to a game, and now we need to initialize these buttons when we go ahead and start the game. So let's go and add code inside the start function, and let's go ahead and say host button dot on click dot add listener. Hosting is basically the process of starting a server and connecting a local client to it. Okay, so to do this in fish networking, it's pretty simple. We use what's called the server manager and the client manager. Of course, the server will start the server, the server manager will start the server, and the client manager will start the client connection. Okay, so also in fish networking, you don't always need to have fields or use get component to access network components like the server or client manager, you can simply do instance finder dot server manager dot start connection. And for the client, we're going to do instance finder dot client manager dot start connection. This is when we are going to host a game. Now when we're going to try and connect to a game, we're just simply going to say instance finder dot client manager dot start connection. And that's pretty much it for our basic multiplayer UI, okay? So let's save this and let's go inside of Unity. It did compile, so that's good. Let's go ahead and create a new canvas. And I'm going to call it just canvas, and I'm going to change the name of my event system. And let's configure it so it scales correctly on different resolutions, okay? Let's go ahead and say change the UI scale mode to scale with screen size. Let's move the match slider all the way to the right so it's 1 on height. And let's set the reference resolution to 960 by 540, which is a 16:9 aspect ratio resolution, okay? Let's go ahead and create our multiplayer menu game object. Let's make it so it fills the entire screen. And let's add the multiplayer menu script, okay? Let's go ahead and add a couple of UI buttons. Just need to import some TMP essentials. And let's go ahead and put them in the corner over there. So, yep, let's go 150. Let's call this host button, and this one connect button, okay? So let's move this down over here, and let's change the text on the host button to be host, and the text on the connect button to be connect. Let's assign the references, and that's pretty much it for our multiplayer menu. And now we can go ahead and enter play mode to test and see if our code works. You'll notice that when the game started, the network manager was moved to a don't destroy on load scene, and that it added a bunch of extra components. That's one of the good things about fish networking. That is, if you don't add all the necessary components, the network manager will automatically add them for you, and they will have pretty good defaults, okay? So yeah, that's one of the good things about fish networking. So let's go ahead and test and click on host. As you can see, it will say that a local server has started, a local client is starting, and that the remote connection for ID 0, which is like the local client, has started, okay? But as you can see, nothing has happened so far, like we didn't load into a different scene or anything. That's because we didn't yet add a default scene component or use the scene manager to load any different scenes or stuff like this. We're gonna cover this, but now let's go ahead and exit play mode, make a quick build. And while the editor builds, let's see, we have two messages from Bogdan again. Which game or project have you worked on with fish networking? I have worked with a ton of personal projects, from board games to first-person shooters to basic turn-based RTS games. I would say it fits it works very good with any kind of game, but it all boils down to how good you are with the framework, okay? And thankfully there is a bunch of video tutorials and very good documentation that's constantly being updated by First Gear Games, which is the developer of Fish Networking. Another question from Bogdan, have you worked with Mirror? If yes, which disadvantages it has compared to Mirror, in your opinion? I have used Mirror before, and in my opinion the biggest deal breaker for me was first performance. And secondly, race conditions. A lot of my games rely on referencing, a lot of objects in my games rely on referencing each other and being in sync when the game starts for late joining clients and stuff like this. Mirror doesn't really support this. There are some really dirty hacks you can do to achieve that, but in my opinion, it's not worth it. In Fish networking, on the other hand, there are no race conditions, and the performance is amazing. There is actually a benchmark on First Gear Games' website over here. Let's see, performance benchmarks, Fish networking versus Mirror. Okay, as you can see, when you have 200 clients connected to your game, Mirror loses 83% of its performance, while Fishnet loses only 7.4. When there are 200 clients connected, the bandwidth consumption with Fish networking is 29 megabytes sent and 2.2 megabytes received, and 94.3 megabytes with Mirror sent and 4.8 megabytes received. These results, some people might say they are like first-party benchmarks and stuff like this, but on the Discord community, a bunch of amazing people did a lot of amazing benchmarks and created some crazy projects. And so far, whenever they compare it to Mirror, the advantage is very obvious. So yeah. Another question from Bogdan here is, what disadvantages does Fish networking currently has, I think? Yeah, in my opinion, I don't see any deal breakers or major disadvantages, except it being new, which means there is going to be less tutorials and less resources available for it. But the community behind Fish networking is just awesome. The developer is very responsive and very transparent when it comes to a lot of things, and there is a lot of experienced people on the Discord server that will help you instantly when you join the community. And that's pretty much it, in my opinion. All the disadvantages that could affect that Fish networking has, and they are not really that much of a deal breaker, in my opinion. It being new will not last forever. So yeah, that's pretty much it. Let's go ahead and continue. So we did a quick build so we can test the client and the host. So I'm going to go ahead and clear the console, enter play mode here. I'm going to start a host. So this is now the server. Let's clear the console and click here and click connect. And as you can see, remote connection started for ID 1. So this means that our client here successfully connected to our host over here. Okay, now let's close this, and it automatically disconnects. Let's exit play mode again, and now let's add a a basic scene switching system, or let's preferably use the default scene component that comes with Fish networking. Okay, so let's go ahead here and click add component and search for default scene. The default scene component is pretty simple. You just assign it an offline scene and an online scene, and whenever a server or a client starts, it will automatically switch between the scenes. Okay, so in this case I have scene 1, which is my offline scene, and scene 2, which is going to be the scene that has all the action. Okay, the start in offline checkbox just is there to ensure that you always start in the offline scene. Okay, since we are always going to start in it, I'm not going to check it. Okay, let's save and let's go ahead and test our game now. Let's make sure that we have the scenes assigned here, and let's enter play mode. So here, if we click host now, we should move to scene number 2, which is indeed the case. And since we didn't mark our UI to move with the network manager, it will be unloaded. So let's test a client by quickly building. So I'm going to enter the game, enter play mode here, click on host. So we have started the server now and move to scene number 2. Let's go to the client and click connect, and we indeed start and go to scene number 2. Awesome. One of the things you might have noticed is that fish networking doesn't require you to have a player object by default. This is a pretty good feature that allows you to create, to not rely on having a player object. You can use broadcasts, send messages between the client and the server, and this doesn't tie you to like the idea that you're always creating a game. You can create applications with fish networking as well. Okay, so let's go ahead and begin creating our player script. Okay, so let's go ahead here and create a new folder. Click player components. Let's create our player script and open it in Visual Studio. We're going to make our class sealed and remove all the default code and remove unnecessary namespaces. And let's begin writing the network code. Okay, first we're going to, instead of inheriting from mono behavior, inherit from network behavior, which is fish networking's version of mono behavior that's networked and allows you to use network callbacks, use synchronized, sync vars, sync dictionaries, lists, etc. So our player object is not going to be the thing we control in game. It's just going to be the this identification or presence for the player that just connected, which allows us to have a different object called the pawn, which will be the thing that we actually use to control and move around within the world. Okay, so our player object is going to have a async var, and we're going to public string username, call it username. It's going to be a string, and as you can see here, this sync var attribute makes it so whenever you change the value of this field on the server, it will be automatically synchronized to all clients. Okay, notice what I said, you need to change it on the server. Okay, cool. Now let's go ahead and add another sync var. It's going to be public pool is ready. Basically when a player joins the game, he might have to do something before starting the game, or you might have a lobby that you want your players to be in before the game starts. So, and you might have some sort of countdown. So this is ready field here is just to make sure that you don't accidentally start the game or begin the countdown before the is ready. All players are ready. Okay, and now we're going to go ahead and save. Let's remove this namespace now. Or let's actually keep it because we're going to be using some of the Unity Engine stuff here. Let's go back to the editor and wait for it to compile. Let's clear the console and let's go ahead and create our player prefab. Let's go ahead and add a player component to our player game object. And as you can see here, when we add a network behavior, a network object component is automatically added. A network object is basically an object that can be obviously networked or spawned on the server and be visible on the client, on all the connected clients. And it allows you to use stuff like, what's it called? Oh yeah, that's sorry, that's a totally different thing. Excuse me, I just got sidetracked there for a second. So basically, if you want an object to be able to spawn on the server and be synced to other connected clients, you will need to have a network object component present on it. Okay. So hi, Alonso or Alonso. Will this live be deleted? No, this live will remain on YouTube. Okay. And in case something happens and it is for some reason deleted, I'm going to share the project on GitHub, and I'm going to upload a video that pretty much covers the same thing in, you know, less detail, but it will hopefully remain, and you will be able to access the project and the source files. Okay, so now that we have created our player game object, let's drag and drop it inside our assets folder to create a prefab, and let's remove it from the scene. Let's create a new folder and call it prefabs, and let's add the player prefab inside of it. Okay, once we have created our player game object and player script and player prefab, now we'll need some way to spawn it in our scene. Okay, luckily it's very easy to do via code, but Fish networking allows comes with a player spawner script that allows you to spawn a player prefab in network scenes when a client connects. Okay, so let's go to our network manager. Let's go ahead and add a player spawner component. Okay, as you can see, it will ask for a player prefab, so drag our player prefab here, and I'm going to add to default scene. This is useful when you are doing a scene loading with the scene manager, which is a totally different topic that we will not be covering in this video, so I'm going to simply uncheck this field over here. And the spawns array is this list of transforms that act as spawn points for the players. This is not going to be very useful in our case because the player object itself is just an empty game object that will exist in the scene for the purpose of identifying players and stuff like this. Okay, so we're just going to leave it empty. And now if I save and enter play mode, when I click host, I should find that a player object has spawned in my scene, and it's the case indeed. Now I'm going to make a quick build to test if the client does the same. Okay, thanks for letting me know, Stephen, and welcome to the stream. Is this better? Let me know, please. Okay, so let's go ahead and test if when we connect the client, the player object will spawn or not. So let's go ahead here, click on host, and click on connect afterwards. Okay, and now we'll find that two player objects has indeed spawned in the scene. So one of them is for our localhost client and one for the remote client that we just built and connected. So cool. I'm just going to exit the build and clear the console and continue. Oh, better. Okay, thank you. Now, since we have created the basics, let's go ahead and create our first kind of complex component, which is the game manager. The game manager is the component that will allow us to start or stop the game, like the game, not the server. Okay, it will allow us to have victory conditions. It will allow us to have a lobby, so that we can track number of players and whether they are ready or not. Okay, so let's go ahead inside the scripts folder and create a new folder, call it managers. Excuse me. And inside this folder, we're going to create a game manager component. Let's double click to open it. And let's seal this class. And let's remove the unnecessary usings, remove the default code, and change mono behavior to network behavior. Okay. Since our game manager is going to be since there is only one instance of our game manager that's going to ever exist on the server, we're just going to make it a singleton. Okay, so let's declare a new static property called instance. So public static game manager instance, and it's going to be publicly retrievable and can only be set from inside the game manager class. Okay, so and let's go ahead and declare an awake function, and inside the awake function we're going to assign the instance to this. Okay, And since our game manager is a network behavior, the reference to it is going to be synchronized across the network. And yeah, that's pretty much it. Let's go ahead back in Unity. Go to our second scene now and add a game manager object and add a game manager component. So yeah, now we have our game manager, and we need to make it so it can track players and start and stop the game. So let's begin with player tracking. Fishnet working comes with a bunch of data structures that are synchronizable, like a sync list and a sync dictionary and a sync hash set, etc. So let's go ahead and utilize a sync list to be able to track the players in game. So here I'm going to go ahead and declare a public read-only sync list, and the generic type is going to be player, and we're going to call it players and assign it to a new instance of sync lists. If you're using Unity 2021.3 like me, it supports C# 9 features, almost all of it. So we can, instead of saying new sync list player, we can simply say new. Okay, this is all good, but in fish networking you need to mark any custom sync type, like a sync list or a sync dictionary or even custom sync types that you can create as sync objects. Okay, otherwise this will give you an error. And to demonstrate this, let's comment out the sync object attribute and go back to Unity. You'll see that Fishnet warns us that players within game manager is a sync type, but excuse me, is missing the sync var or sync object attribute. Okay, so let's go ahead and add it back and go back inside of Unity, and we should see that the error is completely gone. Now, to add the players to the game manager, it's pretty simple. Let's open up our player script and override a couple of methods. Not methods per se, but they are like network callbacks. They are essentially methods, like onStart client, onStart server, and there is a bunch of of them. All are documented here on Fish Networking documentation website. So let's go to network behavior, guides, network behavior, and callbacks. As you can see, there's a bunch of callbacks like onStart network, which we're going to use, onStart client, onStart on ownership client, onStop client, etc. Okay, what matters for us right now is the onStart server and onStop server. Okay, I'm going to go ahead in inside my player script and override onStart server and override onStop server. And when when overriding the network callback methods, make sure to always call the base method and call it first. Call it first before anything, okay? Because this might, like calling it last or not calling it at all, will cause some pretty undesirable side effects sometimes, and it can be very hard to debug, so keep that in mind, okay? When we start the server now, I'm going to say game manager instance players add this, and when we stop the server, I'm going to say game manager instance players remove this. Okay, but since our game manager our player field over here, our player list, is marked as read only, Unity will not serialize it. Okay, so we'll need a different way to debug the number of players. So let's go inside the update function and add a debug.log players.count. Okay, so each frame is going to log the number of players, which should let us know the number of connected players. Now I'm going to go to scene number 1, excuse me, and enter play mode again. Now when I click host, you'll see that it's logging 1. It first did log 0 for 28 frames, when the server was initializing and before the player called, before onStart server was called on the player. So yeah, that's working fine. Now let's go ahead and do a quick build to test that it's working correctly when multiple players are joining in. So I'm going to click host here. I'm going to go to my player, click connect, and you'll see that it's calling, it's printing 2 now, since we have 2 players. And if I go ahead and disconnect my client, you'll see that it's logging number 1 again. Okay? So yeah, pretty cool. Let's exit play mode and clear the console. Now let's go ahead and add some logic to our game manager related to the player readiness and stuff like this. Okay, so we're going to have a sync var called public pool can start. This is a sync var that can be used by the people, like the other scripts, to decide whether the game should start or not, and it's going to be set on the server only, so that because you can set because you can't set the value of sync vars outside of the server. Okay, so let's go inside the update function, and I just said that we need to set it on the server. Okay, how can you do this? Okay, there is multiple ways of doing it in fish networking. You can call a server RPC, which is an RPC that's sent from the client to the server, or you can directly change it on the server if your network object is a server-owned object. Okay, or that it's basically like an object owned by the host's client. So fish networking has a bunch of useful checks like is client, is host, is server, and much more. So in my case here, I'm going to say if not is server, return. So if we're currently not executing the code, or if we're not on the server, don't execute this method. Okay, exit it immediately. So let's go down and say can start equals players with all. The all method is an extension inside the system.link namespace. Okay, excuse me. It allows us to basically iterate over a collection, and if all the items match a specific condition, then it will return true. Okay, so I'm going to pass it a lambda function, and we're going to give it a parameter called player, and we're going to return player.isReady, which is our sync var that we added previously. Can start is going to be now true if all players are ready. If a single player is not, it will not be true. So let's go to our player now and demonstrate our first use of server RPCs. IsReady is going to be IsReady is going to be assigned from multiple different clients. So if we do assign it directly on this inside our update function, or inside our start method or whatever, it's going to work only on the host's client. Okay, since the host's client is present on the server. But what if we have a client that's not? How do we set a sync var? Luckily, we have what's called server RPCs. A server RPC is an RPC that's sent from the client side to the server side. It allows you to execute code from the client on the server. Okay. Correction, not execute code, call code to be executed on the server side. Okay, from the client. So let's go ahead and say private void server set is ready, and we give it a pool called value, and inside the body of this function we're going to say is ready equals to the value. Excuse me. I'm going to make this public because we might need to access it from the UI later. So what basically this means is we are declaring a server RPC that takes a boolean and it sets the value of a excuse me, a sync var to the value of that boolean. I'm using the prefix server here just to make it clear what function is what, like what should be executed where, but you can use whatever. You are not tied to a specific naming convention, okay? Now let's go ahead and add an update method. And inside this update function, we're going to need a way to decide who is the local player or who's the owner of this player object, okay? And to do this, Fish Networking provides us with a very good check called isOwner. isOwner. So isOwner is basically true if this object is owned by the connection, okay? So as we did before, we started a host and we started a client. If we attempt to execute the server RPC without the check, it will simply execute on the client and attempt to execute it on the server, which will not work, okay? So let's go ahead and invert this and return. So basically we're saying if this object is not owned by the local connection, exit the method, okay? And we're going to say if input dot get key down keycode dot r. We're going to say server set is ready, not is ready. So what does this mean? It means that whenever we press the R key on our keyboard, it will send an RPC to the server containing the value or the inverted value of our isReady field. So if isReady is true, it will send false. If isReady is false, it will send true. Okay. Now let's go into our game manager, and to confirm that can_start works, we're going to add a debug statement down here. So debug.log can_start equals can_start. Okay, and let's just double check that everything is fine. Yeah, let's go back to Unity, and it did compile, which is cool. Let's go ahead and enter play mode. Now I'm going to host, and you'll see that it's printing client start can_start equals false. So let's go ahead and press R, and now it's printing true since there's only one player connected. So when he becomes ready, it will be true. Okay, so let's go ahead and make a quick build. Let's enter play mode. Let's click host and open our player, click connect. Now I'm going to press R on the host, and you'll see that it's still printing false since only one player out of the two is ready. Let's go to our player and press R, and you will see that it's now saying true since both of the players are ready. And let's check our player objects, and you can see that isReady is synchronized correctly. Even our client object is, our client player is synchronizing correctly, as you can see here when I toggle the ready state. So yeah, that's pretty cool. Let's go ahead and start adding some complex functionality. And they're not really that complex. We're just going to start adding the movement and rotation of the pawn. So what you might ask, what's a pawn? A pawn is basically what's going to be controlled by the player, okay? It's the actual character that will be moving around, shooting, and doing all kinds of crazy stuff, okay? So let's go ahead inside our scripts folder, create a new folder, call it pawn components. And inside the pawn components, we're going to right click, create script, and we're going to call it pawn. once it's created, let's go ahead and do as we do usually. Let's seal the class, inherit from network behavior, remove the included code, and get implementing. So our pawn is going to have multiple different variables, okay, like health, maybe armor, whatever. But in this case, it's going to have two important fields: the health field, which is going to decide the health of the pawn, and a reference to the player that owns this pawn, okay? So how do we do this? We simply go ahead and say sync var public player owning player, or a better name is controlling player. So this is going to be a reference to the player that's controlling this pawn, or basically, the player that spawned this pawn and is controlling it, okay? I'm going to go ahead and add another sync var and call it public float health. So this is going to be the health of our pawn, and yeah, that's pretty much it. Let's go to the player and add a a field that references the pawn that we are controlling, okay? So sync var public pawn controlled pawn, okay? So now you might say, how do we spawn this pawn object? And I'm going to show you in a second. Let's just go into the editor, and it did compile already, which is cool. Let's set up our pawn game object first. Let's go ahead and create empty, call it pawn, and we're going to reset the transform. And before we progress any further, I would like to quickly go ahead and install a package from the Unity registry called addressables. Addressables is a modern replacement for old stuff like the resources class and the asset bundles. It allows you to load assets at runtime using name and stuff like this. I usually use them instead of directly referencing the pawn in a field or anything like that, because it gives me more flexibility. Like I can have multiple different characters, spawn different types of pawns depending on the class of the player, etc. So I'm going to go ahead and install it. It's not going to take that long, hopefully. We have 6 people watching, which is absolutely amazing. Okay, and it did install. There is this bug with Visual Studio that after installing the addressables package, it usually doesn't pick it up, so we need to exit it and reopen it real quick. And after we do so, let's go to Unity again and select our pawn and continue setting it up. So we need to obviously have a pawn component. We're going to set the health to 100 by default. We're going to leave the controlling player none or null as it is, and we're going to add a 3D object, a capsule, as the body, and we're going to remove the capsule collider. We're going to go back to the pawn and add a character controller. Okay, let's see. Yep, as you can see here. Let's go and real quick generate the lighting. Oh no, that's not the right scene. So let's create a prefab of our pawn, save our scene, remove it from here, and go back to scene number 2. And let's open up our pawn prefab. So as you can see here, it's a white capsule. Now, as you can see, we added a character controller component because we will obviously need our first-person shooter game to have movement. Yeah, and we're going to create a couple of new components, one for the movement and one for the, actually 3. One for the input, one for the movement, and one for the rotation. You can, of course, do whatever you like, but I usually just like to decouple movement and character-related stuff, okay? So I'm going to go ahead here and create a new script and call it pawn input. Open it up in Unity. Seal the class. And it's not going to need to be a networked object because we're going to simply reference our pawn component, which is already a network object. Move all the extra code. And now, or actually let's make it simple on ourselves and let's inherit from the network behavior class. Okay, you can of course do it in a different way, but I just, gonna use it here and inherit from network behavior here just for the sake of simplicity. So let's go ahead and add a private pawn, which is just going to be an internal reference to our pawn component. And yeah, let's go ahead and add an update function and add our input fields. So the first input fields are going to be floats for the horizontal and vertical input, then a couple of extra floats for the X and Y mouse delta values. So private float horizontal, sorry, actually let's make it public float horizontal, public float vertical, and a public float mouse X and public float mouse Y. Of course, we'll need our players to be able to jump, so let's go ahead and add a public boolean jump. And inside our update function, we're going to go ahead and say if not is owner return. Okay, and to actually retrieve the reference to our local pawn, we're going to do a quick method override here to, sorry, let's override the network on start network callback, which is called once whenever you start as server or client. Okay, say pawn equals get component pawn. And down here inside our update function, we're not actually going to simply just use sync vars everywhere. We're going to use these normal fields because you don't need to synchronize the input from different players. Okay, so let's go ahead and say horizontal equals input get axis horizontal, vertical equals input get axis vertical, mouse X equals input get axis mouse X, mouse Y equals input get axis mouse Y. Of course, we need to assign our jump as well. So let's say jump equals input get button down jump. Yeah, so that's pretty much it for the input. Now let's close this class and go inside Unity. It did compile. Let's add it to our pawn prefab. And actually, let's open it up again and add a couple of extra fields called sensitivity, or just one field. So here, public float sensitivity, and we're going to multiply mouse X and Y by the sensitivity so that it can have faster or slower mouse movement depending on what you like. Now let's go ahead and create the movement component. So right click inside our pawn components folder and create pawn movement component, or script, sorry. Let's seal the class, inherit from network behavior, remove unused code, and that's pretty much it. We need to add a serialized field. This is going to be a private non-sync var float field that actually just defines our speed. So private float speed. We're going to have another one for the gravity scale, sorry, for the jump speed first, and another one for the gravity scale. So how strong does the gravity pull you down? Okay, this is the gravity scale field, and the jump speed is how fast you jump, okay, when you press the space bar. So let's go down here, and what else do we need? Oh, we need a reference to our character controller. And we need a reference to, yeah, that's pretty much it. We don't need any extra references. Oh, we need a reference to our input component. So let's go private pawn input and call it input. Let's go ahead, and just like we did in the pawn input class, we're going to override the onStart network callback method. And inside of it, we're going to say character controller equals get component, character controller, and the input is going to be get component pawn input. Okay. Let's go down to the update and create our update function now. And since we now need to move our local client only, and we needed to move, we need to move it on the client side, since we're going to have client side authoritative movement, or client authoritative movement, we need to add an is owner check. So if you're not the owner of this object, we simply exit the method and don't execute anything. Let's go ahead and begin. So we're going to declare this. The code that I'm going to write right now is simply generic Unity movement code, so you can use whatever. So I'm going to write it real quick, okay? And actually, before I continue, I forgot to add a private vector3 velocity field, which is going to store our velocity between frames. Okay, so let's go ahead and explain this code real quick. We have a local variable here, called desired velocity, which is basically the velocity that our character would like to move at. It's basically multiplying the forward vector of the of the pawn with the vertical input, which is like the W and the S keys, and then it's adding the horizontal input multiplied by the transforms right vector, okay? So that's basically the A and D keys. Then we multiply the whole expression by the speed variable. So wait a second, we need to group these here. And then we call vector3.clamp magnitude on the value of the expression we have here, and clamp it to the speed, so that players holding W and D, for example, wouldn't move at double the speed of other players, okay? Then we assign the desired velocities X and Z to X and Z of the velocity field we have here. Then we check if the character controller is grounded. If it's so, we simply reset the velocity to 0 so we don't have any kind of glitchy idle characters, and we check if the input, the jump field, is true. We simply assign the y value of the velocity to the jump speed. Otherwise, if the character controller isn't grounded, we start incrementing the y by the gravity y value, which is defined inside the editor, multiplied by the gravity scale, multiplied by the delta time. Then, at the end, we say character controller that move, add the velocity multiplied by the delta time. You'll notice that I am multiplying the gravity here by the delta time, then again multiplying the whole vector of velocity here by the delta time. If you didn't add this or this, your character controller will move at an insane speed, okay, and will look glitchy as heck, okay? So I highly recommend you don't forget to add these. Now let's go to Unity, and hopefully it did compile. Yep. Select our pawn, add the pawn movement component. Okay, let's set the speed to something like 5 and the jump speed to 10 and the gravity scale to 2. Okay, and let's go ahead and create a component and call it pawn rotation, or simply pawn camera. Yeah, pawn camera look. Yeah, and open it in Visual Studio. So just like we do every time, we seal the class, inherit from network behavior, and begin adding our fields. The pawn camera look component is going to be responsible for the, of course, camera look of the pawn. So we're going to have a reference to our camera transform, our camera x-axis limit, so the up and down limit of the rotation, and we're going to add a reference to let's see, what else do we need? Oh, the input component, of course, and that's pretty much it. Or sorry, we also need to add a reference to our body, or the character's body. So when we look left and right, it won't just rotate the camera, it will rotate the whole transform. Okay, so let's have a private pawn input field and call it input. We're going to have serialized field, private float x min, serialized field private float x max, and before these let's actually add a serialized field private transform my camera. What else do we need? Yep, that's pretty much it. Let's go inside our update function, and before that let's override the start network callback. Inside of it we're going to add the input component, and that's it. Let's go inside the update, add our isOwner check, and oh, we need to have a field here of type vector3 called Euler angles, which is used to store the rotation of the camera and to allow us to limit the up and down rotation. Let's go ahead and say Euler angles.x plus equal input dot mouse y, and I'm going to tell you why we use the mouse y instead of mouse x when incrementing the x axis. Euler angles.y plus equal input dot mouse x. So in Unity, the x-axis, when you rotate an object on the x-axis, you change the its rotation like up and down, and the mouse y is of course the up and down movement of the mouse. So when we move up, it decrements, and when we move down, it increments. So actually we need to, instead of increasing, instead of adding it, we need to be subtracting it from the x-axis of the vector called Euler angles. And the y-axis here, we're going to be increasing or adding the mouse x to to its value, because when the mouse moves left and right, of course, that's the rotation on the y-axis in Unity. This differs between engines, so just take it from me. X is up and down rotation, Y is left and right rotation, okay? And right here I'm going to say Euler angles.x equals mathf.clamp. Need to change this to clamp the Euler angles.x to x minimum as the minimum value and x maximum as the maximum value, so that we don't go over or below the minimum and maximum rotation. Okay, and right here, this is actually a mistake, so we need to mitigate it. I'm going to remove this line. I'm going to say transform.rotate, and this is because I would like to rotate the entire transform, not just the camera. Input dot mouse y. Let's see, yeah, and then say 0.0 and rotate in the world space. Okay. So far, if we try and use the script right now, we'll see that our character rotates left and right only. That's because we didn't assign the Euler angles to the camera reference Euler angles. Okay, so let's take a final look here. That's pretty much it for the camera look component. Let's go into Unity. Let's go to the pawn. Let's add a camera look component, and let's create a camera for the pawn. So camera here, to move it here, or you know what, let's just place it right here. I would like to apologize in advance because there are some neighbors that are just having some kind of party or just chatting somewhere, and they might sound in the mic, okay, so excuse them. Let's change the values of the camera, and let's go to the pawn and assign the references. So I'm going to assign my camera here, and I'm going to say the minimum rotation is -90 and the maximum is 90. Okay. This is pretty much it for the pawn pawn game object. Let's go ahead and set the sensitivity to 2 instead of 0, so we can actually look around. And yeah, the final thing we need to do is select the pawn prefab, and you see this addressable checkbox here. Let's check it and change the address to pawn, just like that, so we can load it from code, and I'm going to show you how to do that right now. Let's go ahead and see where we have our player script here, and we're going to go ahead and say, just for testing, this is not the final product. We're going to say if input get key down kcode dot let's see, I, for example. We're going to say server spawn player, and let's actually create this function. So private void server spawn player. Oh, excuse me, it should be called server spawn pawn. That's just like a very weird name, like spawn pawn. It's very hard for me to pronounce. Yeah, so let's go here and say server RPC, and inside here let's begin by loading our pawn prefab. To do this, all we have to do is simply say game object pawn prefab excuse me, equals addressables dot, oh, what the heck, addressables dot load asset asynchronously or async, and give it a type parameter of type game object, and give it the pawn as a key, and then say dot wait for completion. The reason I do wait for completion is because I would like to load it synchronously. You can do it asynchronously, but just for the sake of simplicity, we're going to do it synchronously. Once we load our prefab, we're going to go ahead and say game object pawn instance equals instantiate pawn prefab, and let's go ahead and call spawn the pawn instance. And let's stop here for a second and explain this. The spawn function allows you to spawn network objects on the server, and they will be automatically spawned for clients. If I just call spawn like this and pass it the instance of our pawn, it's simply not going to be owned by our local connection, so it won't work. So you might ask, how do we make it, or how do we own an object, or sorry, assign ownership when we spawn it? Excuse me. You simply pass it a connection that it should be owned by. Okay. In our case, we'd like it to be owned by this local connection's owner. Okay. So I'm going to say owner, and that's pretty much it. Okay. So now when we spawn this instance, it will be owned by our local connection, and we are the only ones that are going to be able to control it. Now let's save and let's go into Unity. And we missed a very important part. Let's go to our pawn prefab here and add a network transform component so that we can actually synchronize the position of our clients to each other. Okay. Since we're not going to be changing the scale, we're going to disable scale synchronization. We're going to leave everything else as default. Okay. Let's go into our second scene and add some sort of ground so that our pawns can stand on it. So we're going to go here and create a new plane. Let's call it ground. Let's move it down like to -2.5, so that when we spawn, we don't just, spawn into it and fall through it. I'm going to give it a nice blue color. Okay, or let's actually give it a green color. And now when we go to the first scene, if everything is written correctly, which I'm pretty sure it is, everything should work fine, and we should have a pawn that moves and looks around. So I click host and I press I, and it did in fact spawn our pawn here, and we can move left and right, but we can't really see. This is interesting. So our first bug so far. Yeah. For some reason it's not rotating on the left and right axis. So let's see what's the problem here. Transform.rotate my camera.Euler angles. Interesting. Let me see the input, make sure everything is correct. Yep. Let's go ahead and see our pawn component. Sensitivity, and everything seems to be fine. Let's try again. Maybe it was just like it seems like something is preventing the pawn from rotating. Oh, I'm so dumb. Yeah, it's because I'm assigning the Euler angles to the global Euler angles, when in fact I need to assign it to the local Euler angles. Excuse me for this one. Pretty nervous mistake. So let's go back into our play mode, click host, and spawn our player, and then we can look left and right. Still not working for some reason. Oh yeah. I did things incorrectly, I assume. Somewhere here, yeah. So the clamp, minimum and maximum, the X value. Everything should work. This is not working for some reason. It's probably a very stupid mistake. Okay, let's see once more. What the heck is going on? So our pawn is rotating, but it's rotating on the same axis on, maybe it's a typo, right? It is definitely a typo somewhere here. Yep, I'm just so blind. I was using the incorrect axis right here. Yeah, so let's go back, and this should be fixed right now. Click spawn. Yeah, I can look around, I can move, I can jump, and everything is fine. Now let's go ahead and test with an extra client. It's building right now. Let's click play here and host the game. Spawn our host client and move backwards. And there is a bug that's going to come up right now, and I will teach you how to fix it, but let's just go ahead and switch to our client and connect and spawn our instance here. As you can see, we can move around and synchronization is working, but the cameras are like overriding each other. So how do we fix this? It fixes pretty simple. We simply go ahead, let's close these, and go here in our pawn camera look, and we're going to override a new network behavior callback called onStartClient. So this is called when we start, when the client starts and our object is fully initialized on the client. Let's go ahead and say if is owner, or basically let's write in a shorthand form. So we say get component or my camera get component camera that's enabled equals is owner, and my camera that get component audio listener that enabled equals is owner. So this basically means that when we spawn, if we are present on the owner's machine, the owner's instance of the game, we're going to enable the camera and audio source, otherwise they're going to be disabled. Okay, let's go ahead and build this. And let's go ahead and enter play mode here. Click host, and here, spawn our pawn instance. And let's go to our client and connect, and then spawn. As you can see, the cameras now work correctly. You can move around here and jump around, and everything will be synchronized. And if I go into the editor and move, then take a look at my client, everything is working correctly. So that's pretty cool. I'm going to take a break for 1 second, okay, and not 1 second, like 2 minutes, and then I'll be right back, okay. Okay, I'm back now. Let's continue. So we have added our pawn component, we have added movement, rotation, and jumping, all this cool stuff. Now let's go ahead and add some logic to the game manager so that we can start the game from it and stop the game from it as well, okay? Let's go ahead and open the game manager and add a couple of functions. So the first one is going to be public void start game. Second one is got public void stop game. Oh, hello Red3 Tango. Thank you for saying Boolean, not Boolean. Yeah, yeah. I'm not a fish person. I am just a normal human being. We don't say Booleans here. Yeah. Okay. So back to our code. Now we have the start game function is going to tell all the players that the game has started. Okay, and that they should spawn their pawn instances. And the stop game method is going to tell the players otherwise, you know, like destroy all your pawns, the game is over. Okay, this can be like because of this connection, like all the players have left and the game no longer has enough players to continue, so that you stop the game, or that simply one of the players have won and the game needs to stop because of that. Okay, so let's go ahead inside our start game function. And before we add any code to it, let's annotate it with the server attribute, which makes sure that it's only ever executed on the server. Otherwise, we'll get a warning in the console. Okay, let's do the same here. And yeah, let's go ahead inside the start game function and iterate over all our players. So for I is less than the players players.count. We say players I dot start game, which is a method that we are about to write right now. And here in the stop function, we're going to say players dot count players I dot stop game. Okay, that's pretty much it for these two functions over here. We might add to the start game here. We say if not can start return, so that if not all the players are ready, we can start the game. Let's go to our player script and add our two new functions. So here we're going to say public void start game and public void stop game. In the start game, we're simply going to copy our code from the server spawn function here, and we'll actually remove it and simply paste it here. And in the stop function, we're going to need to write some extra code in the start function first. So let's go ahead and do that. You remember our control pawn and our controlling player variables? Now, yeah, we need to assign those now. To do this, let's go in after we spawn the instance of our pawn. We go ahead and say controlled pawn equals pawn instance dot get component pawn. Okay. And then in the stop game function, we're going to check if controlled pawn is not equal to null and the controlled pawn is pawned. So just if for any reason the game is about to stop just as the controlled pawn is being despawned, you will usually get a warning, or I think it will throw an error. So to avoid this, we have the is spawned check. The is spawned check makes sure that your game object, your network object is spawned on the server, and the client, on the server, and is ready to receive RPCs and stuff like this. Okay, so it's like a safety check. Okay, it's very important and very useful. So if both of these conditions are true, we're going to say despawn we're going to call despawn on the controlled pawn here, okay? So despawn. So that's pretty much it for the spawning and the starting and stopping the game. And now all we need is a UI to control the code we have here. So let's just go into Unity, let it compile for a second. And yeah. So the approach I'm going to use here, I usually don't use because in managing UIs, I have a system that I created a tutorial on YouTube. I will link it after the stream is over. It's a very flexible and powerful UI management system. So I'm going to use what's kind of similar to it, but on the same level, you know. So let's go ahead inside our UI scripts folder and right click, create a new script and call it lobby view. And inside this lobby view, wait for the compilation. Let's seal the class, remove the included code, and remove the, what the frick, move the extra namespaces, okay? So inside the lobby view, we simply need two buttons, a button for starting the game as the server, and a button for toggling your ready state, okay? To do this, let's go ahead and add a serialized field, private button, start game, and actually before it, let's say serialized field, private button, toggle ready button, okay? And what else do we need? We might need a reference to the text of the ready button, toggle ready button text. So ready button text. And let's see, what else do we have here? We need a start button, a ready button. Yeah, that's pretty much it. We're going to have a public void init, which is going to initialize our UI. Okay, I'm just going to call it initialize because I hate shorthand names. And inside this initialize function, we're going to say toggle ready button dot onClick dot add listener. Oh, wait. We need to have a reference to our local player instance in order to call the set is ready, server set is ready RPC. So let's go to our player class, go all the way here, add a public static player. I'm not going to call it instance, I'm going to call it local instance. Or in my opinion, it's pretty obvious that the singleton of your player is the one that you're controlling, so I'm just going to drop local. That's the worst programmer struggle ever. It's just the naming of variables. It's always confusing and always time consuming. I hate it so much. Okay. Inside the override on start client function here, we're going to say if not is owner, we return, and we're going to say instance equal this. So basically, if you're the owner, we're going to assign this local player instance to the instance variable, okay? And one thing we need to do is go to the server RPC here and say require ownership equals false. What require ownership means is whether this RPC must be called from the owner only. This is usually a good idea to keep it on to prevent like cheating, but since our UI is not a network object, and you should never network your UI unless you absolutely have to, it doesn't necessarily own the object here, sorry, own our player, so it can't call this server RPC. So that's why you need to say required ownership equal false. So now that we have all this in place, let's go to the lobby view, and inside of it we're going to say player instance dot server set is ready, not player dot instance dot is ready. You can of course have a local reference to the player, but I'm just going to write it on a single line. And inside the start game function, wait a second. Now our start game button dot onClick dot add listener, we're going to say game manager dot instance dot start game. The reason I have no checks here because I'm going to disable the start game button if we are not the host of the game. Okay, how do you do this? Pretty simple. We simply go here and say if is host instance finder that is host. So this basically checks if we are hosting a game, meaning if we have a server and a client active, we do initialize the button, and just in case we say game object that set active to true. Otherwise we say start game button that set active to false. And now inside my update function, I'm going to say, I'm going to need to declare a new private boolean, and I'm going to call it initialized, and this is going to be true only when we have initialized the UI. So we say if not is initialized, we return. Otherwise we're going to say toggle ready button text dot color equals game manager dot instance dot can start color dot red dot green. Oh, excuse me, this shouldn't be like this. It should be player dot instance dot is ready color dot green, otherwise color dot red. So if our player is ready, the text is going to be green. If he is not ready, it's going to be red. Okay, and here in our update function, I'm going to say start game button dot interactable equals game manager dot instance dot can start. The difference between interactable and disabling or enabling the button is that interactable just simply disables the interaction with the button if it's set to false, and enables it if it's set to true. So in our case here, I'm going to set it to true only if our if our game manager is ready to start. Okay, now let's save, exit here, save all, and go back to Unity editor. It did compile, so that's awesome. Go to scene number 2 and let's create our UI. So create a canvas just like we did with the main scene canvas, pretty much the same setup. And inside here I'm going to say create empty lobby view excuse me, and set it to fill the screen like this. I'm going to add the lobby view component, and I'm going to add a couple of buttons. So where do we have these? Yeah, button here. So this is going to be toggle ready button, and then we're going to have start game button. Going to set the width to 200 and the height to 50. Going to align them to the top right corner. So -10 and -10 here. Drag this down. Change this here. Change the text of the toggle ready button to ready, the question mark. and the start game button text simply is going to be start. Let's assign our references, and we should be good to go. Excuse me. Now we need a way to switch between our views. So we have a lobby, and we might have a heads-up display for the player. We might have an inventory view. You get the idea. So we need a decent way, excuse me, of switching between these views, okay? How do you do this? Again, as I said, I highly suggest you go and check out my UI tutorial, because it explains what I'm about to do in more detail. But basically, we're going to have a view manager object, or UI manager object, that's going to allow us to switch between views, okay? Let's go inside the UI folder here, say UI manager, and I'm going to make it sealed, and I'm going to make sure that yeah, there is an instance, so public static UI manager instance get private set. Let's go ahead and have a serialized field, private game object views, okay, which are basically our UI building blocks, whatever views we have in the scene. And since they are going to be only let's see, the lobby view, the heads-up display for the player, and the the respawn screen, stuff like this, let's go ahead and yeah, have an array. So we're going to have a public void initialize again, initialize here, and we need to actually switch this here from GameObject to view, which is a class that we're about to create to simplify the management of different views. Let's go inside the UI here, create a new C# script, call it view, open it up in Visual Studio, and this time it's going to be a public abstract class. An abstract class is a class that has no implementation by default. Sorry, it doesn't implement like methods by default and stuff like this. Sorry, excuse me, this is wrong definition. An abstract class is a class that cannot be instantiated by default, and instead you have to instantiate or use its derivatives to control, to have instances and control the behavior, okay? So I'm going to have a public abstract class called view. I'm going to have a public boolean called initialize, and it's going to be get private set. And I know I have it private here because I intend to only set it inside the what's it called, initialize method we're about to write. Fix this up, and I have a public virtual void initialize. Okay, and simply inside the the default implementation of initialize, we're going to say initialize equals true. So yeah, let's rename this to initialized, set this to true as well. Okay, let's remove the unneeded namespaces, and let's close the view class and go here. Now, since we have an array of views, we can simply iterate over it, saying for each view in views, view.initialize. And let's not forget to assign the value of our singleton. So instance equals this. And we need a method to switch between views, okay? Let's go ahead and have a public void show, and we give it a type parameter of t. And what we're going to do inside this is say for each view in views, actually we need to add a generic type constraint to the t generic parameter. What I just said is basically I would like the t parameter to be a generic type that's constrained to a certain base class, for instance, or a certain interface. So to do that, we're going to say where t is a view. So if you try to pass anything else that doesn't inherit from view to the show function, it will give you a compile time error. Okay, so we go here and say if the view view.gameObject.setActive view is t. What this expression here means is wait a second, what is that? Oh, 1 second please. Okay, it was just a wire that was touching the fan. Okay. Again, now I was explaining this line here. So what view.gameObject.setActive view is t means is that if our view is an instance of the type t, then enable the view. Otherwise, it will be disabled. Okay. So if you're, for example, trying to show the lobby, it will only show the lobby and hide the rest of the UI. Okay. Let's save and let's exit the UI manager. Let's go ahead and go to our lobby view. We need to change some stuff here. So we're going to change mono behavior to view, and we're going to change the public void to public override void, and make sure that we remove this field here and this field here, and call base.initialize at the end of our initialize function. Okay, and let's switch this initialize here with this initialized here. Okay, so that's pretty much it for the lobby view and the basic UI management. Let's go inside of Unity, check our lobby view, everything's fine. Let's go ahead and create the UI manager. So UI manager. Oh, excuse me for a second, I need to take care of this wire thing. Terrible cable management always comes back to bite you in the butt. Okay, so inside the UI manager game object, we're going to add a UI manager component, and you'll see that it has an array of views. We're going to drag our lobby view and add it there. Okay, but now you might be confused. How is the UI manager and the UI views basically a single instance, and multiple players are going to be interacting with them? The idea is, did you see our initialize function here in the UI manager? We're going to only call it per client. Okay, so the client, if the owner of the object, is the only one that's going to call it. So our player is going to call it in his in its onStart client function. So let's go ahead and demonstrate that. Let's go to the player.cs, and after we assign the instance, we're going to say UI manager with instance.initialize. That way the UI is initialized depending on who owns the player object. Okay, okay, Now if we go ahead and go to scene number 1 and enter play mode and you click host, you can see that we have our ready button and our start button is disabled because we're not ready yet. If I click it, it turns on and we can start the game, and we definitely and as you can see, it definitely works as expected. You can see that when I am pressing the space bar button, oh what the heck, yeah, the UI button here is still focused. To solve this, just click anywhere on the screen and the issue will be solved. We're going to fix this by disabling the mouse cursor and removing the navigation events from the event system. So let's do this. Exit here, go to the event system and click send navigation events to false. Okay, now when I try to do the same thing again, that is host the game, ready and start, you can see that when I click space, nothing wrong happens. Okay, let's exit the play mode now and do a quick build to test whether our code works or not. Let's go ahead and enter play mode, click host, ready, and connect another client. And as you can see on the client, even though the UI is shared, the start button is disabled and the ready button is showing the local client's ready state. Okay, if I click ready here, the start button here is going to be enabled, and if I press start, it's going to start the game for both the client and the host. Excuse me, the mic was just bugging out for a second. So as you can see here, we can move around, can jump, and everything is working fine. Now I would like to go ahead and add a heads-up display for the player. Okay, so let's go ahead and create a new game object. Let's go ahead and call it a new script and call it main view, which is like the main heads-up display. Seal it, inherit from view, and override the initialize function. Now let's go ahead and add what we need for our main view. The first thing is a text that displays the health. So serialized field, private UGI. I'm gonna call it health text, and let's have a for now let's just keep it simple and have only the health text. So in this case, we're not going to override the initialize method. We're just going to go ahead and update, add an update function, and check if not initialized, return. And underneath that, we're simply going to go ahead and say health text dot equals health, and we're going to say player dot instance dot control pawn dot health, so that it displays our current pawn's health on the UI. Okay, and let's just make sure that we don't get any null references by doing if saying player equals player dot instance. If we say if player equals to no or player dot control pawn equals to no, we return. And let's go ahead and change this to be player dot control pawn. Okay, let's remove the unnecessary namespaces, and let's save our source files and go to Unity. Let's go to scene number 2, go to our canvas and add our main view. So main view, it's going to fill the entire screen. Let's add the main view component, and let's go ahead and move the text to the top right corner. So 10 and -10 here. Let's center it vertically. Add some placeholder text, so health equals 100, and let's make it red. Okay. Now I'm going to change this to health text. Okay, and I'm going to assign it to my main view, and make sure that you assign the main view, that you add the main view to the views list. Okay, let's save. Let's clean the console, and let's disable these two game objects here, and let's go inside our source code and go to our player. And once we initialize the UI, we're going to show the lobby view when we first connect. Okay, so we're going to say UI manager dot instance dot show, and simply give it the type of lobby view. If you go back into Unity and go to scene number 1, enter play mode, click host, you will see that the the lobby view is automatically activated and the main view is automatically disabled, and we can interact with it pretty much like we do normally. I simply just forgot to go to scene number 2 and remove the send navigation events. So yeah, I just did that. And what else do we need right now is to show the main view when we spawn an instance of our pawn. Okay, which is pretty simple. We're going to use what's called a target RPC. A target RPC is basically a normal RPC, but it's only sent for a specific connection. Okay, so let's go ahead and add one. So here we're going to say target RPC private void target pawn spawned, and we're going to set the first parameter to network connection, which is the connection that we would like to send to. And fish networking has a convenience feature, that is, if you have a default parameter of a type network connection as the last parameter in your RPC signature, it will automatically be set to the owner or the connection that sent the RPC. Okay. I usually don't do this. I usually do network connection like by hand, which I'm going to do right now, but I would just like to bring that up, okay, for any people that like convenience. Okay, so inside the target pawn spawn function, we're going to say UI manager dot instance dot show main view. Okay, and when we call this, we call it on the server when we start. Okay, how do we do that? Since we have the start game function here and it's called on the server only from the game manager, we can simply go ahead and say target pawn spawned and pass it the owner. Okay, now when I go to Unity and wait for it to compile, if I go to scene number 1, if I enter play mode again and click host, when I press ready and start, it will automatically switch to the main view, as you can see. Let's maximize this so you can see that we have automatically switched to the main view. Cool. Now let's test with 2 clients. Let's go into the editor, click host, go to the client, click connect, press ready here and ready there, and when we click start, we'll get the main view and we will get the main view here as well. Now to confirm that the UI is syncing properties properly, since the editor is the host, if you changed values on it, it will automatically sync. But this is a very bad idea. I usually don't set sync vars from the UI ever. except when setting them via prefabs. So yeah, this is just for demonstration. Let's go here, select our pawn, and if I reduce the health here to like 69 or something, you'll see that our health here remains the same. Okay, let's close this and close that. And now let's add the most important thing, and that is shooting and weapons. So basically, our weapons are going to function by simply casting a ray, okay? And when the ray hits something, it's going to send an RPC to that something, if it's a player, okay? And reduce its health until the health is below 0 or a certain threshold, and the object will die and we will have some sort of respawning system, okay? Let's go ahead and create a new component and call it pawn weapon. Inside this pawn weapon script, we're going to seal it and inherit from network behavior. Let's go ahead and add a reference to our pawn. So pawn, and let's have a reference, add a reference to the input, pawn input, and let's add some fields which represent the properties of the weapon. So the first one is a private float damage, and the other one is the private float rate of fire, and finally the last one is going to be a private variable, so private field, private float time until next shot. Okay, oh, excuse me there. And I'm going to rename rate of fire to shot delay, so that it's more like in line with the naming here, okay? Let's go inside our update function and say if not is owner, we simply return. And before we continue, let's override the onStart network. Say pawn equals get component pawn, and input equals get component input, okay? Oh, wait a second, needs to be pawn input, sorry. Let's go ahead and add an RPC. So we're going to call it private void server fire, say server RPC, and we're going to send the position of the muzzle and the rotation of it in this RPC, just to ensure that we're casting the ray from the location that the client sees properly, okay? I know we have network transforms and it will work just fine, but sending it as a parameter is usually preferred in my opinion. So let's do this. I'm going to have a vector3 fire point position and vector3 a quaternion fire point rotation, okay? Or instead of sending the rotation, we can simply send the direction. So vector3 fire point direction, and let's add a transform here. So serialize field private transform fire point. Inside our update function here, I'm going to say if time until next shot is less than 0.0f less than or equal. I'm going to check if input dot fire, which we need to add. We say server fire, sending the fire point to position, fire point dot forward as parameters, and setting time until next shot equals shot delay. Okay, otherwise we simply say time until next shot minus equal time the delta time. Let's go to the pawn input component here. and add a public boolean fire, and this fire is going to be equal to input.get button fire1. By the way, all the names you find here are automatically defined, are defined by default in all Unity versions, okay? So you don't have to worry about defining them yourself, okay? Usually I would use the new input system, but this is just for simplicity's sake. Okay, once we do all that, let's go inside our server fire function and say if physics raycast fire point direction, fire point position, fire point direction, out raycast hit. We check if casting a ray from the position of the fire point in the direction of the fire point will hit anything, and we did hit an object that has a pawn component, like here. We're going to say pawn dot receive damage, okay? And the amount of damage received is going to be the damage field we have above, okay? Now let's go ahead and add this function. So public void receive damage float amount, and we're going to say if health minus equal amount is less than or equal to 0.0f. Do this right here. We say despawn, and let's add a check up here like we did before. Say if not is spawned. So if this pawn is being has already died and is just despawning, we ignore the method, okay? Otherwise, if decrementing the health by the amount of damage we just received is less than or equal to 0, just despawn the pawn, okay? Let's go to the pawn weapon here, and everything is fine. Now let's go into Unity, go to our pawn object here, and let's add a simple cube as the gun. Let's call this one gun. Let's move it so the camera can see it. Okay. Let's disable these and the camera here. Just pointless for a first-person shooter as simple as this. Let's remove the box collider. And let's see. Let's go to our pawn and add the weapon component. Let's set the damage to 35 and the shot delay to 1. Let's go and set the fire point to be a new empty game object. Let's call it fire point. Let's move it here. Let's go ahead and assign it. Okay. Usually casting a ray from the middle of the screen using the camera is much better to avoid clipping issues and stuff like this, but since this tutorial is just for simplicity, for like getting you to understand the basics of fish networking, we don't really need to go that deep into this stuff, okay? I'm just letting you know. Now let's go to scene number 1, and let's go ahead and make a build real quick. Let's go into the editor and enter play mode. Click host, ready, connect our client, press ready, and start the game. When I start here, if I do 1 shot, let's inspect the, okay, as you can see, the health of our enemy decremented. And if I go ahead here and if I just can get my mouse to look here, so if I shoot, yep, you can see that the health decreases on the host as well. And if I go here and finally shoot this player enough times, so 1, 2, you can see that it did actually despawn, and it's back to the main camera again. So yeah, we have shooting working now. Let's go ahead and add a basic respawn system. So let's go ahead and see the scene number 2. Let's add a new empty game object and call it respawn view. Let's go ahead and create a new script and call it respawn view. Let's open it up in the inspector, in Visual Studio Code. Let's seal it, inherit from view. Go ahead and add a private field, call it respawn button. Let's override the initialize method, and inside of it, let's go ahead and say respawn button and click add listener. So let's think about how to add the respawning system before we actually begin. Excuse me, I was just checking the stream chat to find if there is anything new. We have 6 viewers so far, which is amazing. Okay. To do the respawning, we need to send an RPC from the pawn object to the player, telling the player that it did die, okay, and that it needs to switch the view to the respawn view and allow the respawn of another pawn object, okay. This is pretty simple. All we have to do is go to our player CS, add a public void target pawn killed, network connection we are intending to send to, say target RPC. We simply say UI manager dot instance dot show respawn view, okay. And to call this, we need to go ahead and go to respawn view here and say oh, excuse me, just got confused there for a second. Let's go to the pawn CS script, and inside before we call this pawn, let's send an RPC to our controlling player. So controlling player dot target pawn killed, and pass the owner as the network connection that to send to. Now we need to set the controlling player. So let's go to the player.cs, take a look here, and say controlled pawn controlling player equals this, okay. Now we also need to expose a function to reinstantiate to basically execute this again. So let's go ahead and add a server RPC wrapper. So here, public void server spawn pawn again. And let's mark it as a server RPC and simply call the start game function inside of it. Of course, you'd have a different naming and a different method layout. This is just for giving you a rough idea, okay? A rough idea of what you should be doing. You should, of course, restructure your code to be better than this and to be more consistently named and arranged, okay? But as I said before, this is just for simplicity. This tutorial is intended to give you an idea. So let's go to the respawn view and finally call player.instance.server spawn pawn. Okay, now we need to do set the require ownership to false on this RPC as well, since as I said before, the UI doesn't own the object. So let's go here, and yeah, that's pretty much it. We go to Unity, going to scene number 2, go to respawn view, add the respawn view component, and simply add a button to the UI and call it respawn button. Center it in the middle of the screen, set its width to 200 and height to 50. Oh, wait a second. 50 pixels, and change the text to be respawn. Let's disable it, and before we switch scenes, let's add it to our UI manager views array. So let's see, what else do we need? I think, yeah, let's go to our pawn and change the gun to be a child of the camera, so it's a little bit better, you know, like all normal FPS games. And let's move the gun a little bit to the right, sorry, left, and let's move it up a little bit. Yeah. So let's go to scene number 1 and do a quick build. Okay, let's go in the editor, host game, then connect and start. Okay, now I'm going to start shooting this player, so it's going to die, and if I switch to the other view, you'll see that it did add a respawn button, and if I click it, I respawn again, and I can shoot the host, and the host will show the respawn view, and I can respawn, rinse and repeat. Yeah, so that pretty much covers it for the basics of creating an FPS from scratch in fish networking. I know for a fact that this is not the best tutorial ever, but it's just a, okay, again, intended to give you a rough idea on how to get started. Okay, in the future I intend to do more live streams like this, where I add complex stuff like animation, and I structure the project in a more how do I say this, long-term way, you know, a way that's easily maintainable. And yeah, so that's pretty much it for today. There are 3 people right now, 4 people right now in the live chat, so I'm going to stay for extra 10 minutes. If there are any questions anyone would like to ask, you can go ahead now, please. Alright, Flash 3838 sounds great. Thanks for making tutorials. You're welcome, Flash. Thank you for being with us on the stream. Thank you for coming, it means a lot. Anyone else has any questions? Okay, it seems not. Okay, so let's go ahead and show before I exit the documentation links of fish networking. So I said at the start that fish networking is a new solution. Okay, so it's a little bit light on documentation and stuff like this, which is not really all that true, since it has a pretty in-depth, you know, pages on pretty much everything that you need to get started, like transports, managers, guides for using certain things like the one I used, the network behavior one. Okay, and also there is the API documentation, which has documentation for literally everything Fishnet has, like all the classes, all the fields, all the events, whatever you need. So for example, if I would like to see what fields or what methods does the server manager have, simply search for it and it will show up here. You have the fields, and they are, like, I think that 70% or even more of the entire API is covered, and documented, and plus you have XML documentation comments in Unity that first gear games added. So for example, if I go to my weapon CS and I highlight over the server RPC, you'll see that there is a message here that tells you what this particular attribute does. So yeah, that's pretty nice. And again, the API documentation is usually very helpful if you're searching for a certain thing, like a certain functionality. Like for example, if you'd like to know the number of players connected, you can use the server manager.clients field. If you'd like to start a connection like we did, you can go to methods and you can take a look at the start connection method. If you'd like to disconnect, you can take a look at the stop connection method, and so on. So yeah, I would say that Fishnet is awesome. I absolutely love it, and I highly recommend people to who are, like, not all people of course, people who are intending to create multiplayer games to use fish networking, because it's future proof, and in my opinion it offers more features, and it's very easy to use and easy to get started, as I showed you in this video. Okay, I hope you enjoyed the stream. Does anyone have any questions again? We still have 4 people online. Okay, so it seems that there are no questions. Okay, thanks to everyone who showed up, and thanks for watching till the end. I will hopefully create a new another live stream soon, and it'll be much better than this one, of course. And yeah, that's pretty much it. Thank you for watching. Yeah, not a great way to end the stream.